Welcome to episode 78 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
From convolution to Facebook AI, today we dive into the life and work of Yann LeCun, one of the most influential figures in artificial intelligence.
Yep, the man behind convolutional neural networks, who later helped shape AI at Meta, formerly Facebook. His story is a perfect mix of deep theory and real-world impact.
So let's start at the beginning. Yann LeCun is a French-American computer scientist and a pioneer in deep learning. His major claim to fame is inventing and popularizing convolutional neural networks, or CNNs for short. Unlike traditional neural networks, CNNs are designed to work really well with images.
Which basically means computers learn to see and recognize patterns much more like humans do, looking at parts of an image rather than the whole picture at once.
Exactly. Think of a convolution like looking through a small window across a large painting. Instead of trying to process the entire painting all at once, the network scans piece by piece, recognizing edges, shapes, textures, and gradually building up an understanding.
That scanning technique dramatically improved image recognition tasks, and the impact, well, from automatic tagging in your photo app to recognizing defects on factory lines, CNNs are everywhere.
Historically, convolutional nets grew out of earlier neuroscience-inspired models. Yann's key insight was combining local receptive fields with shared weights, meaning the same small filter scans across the entire image, reducing the number of parameters and making training on large data sets computationally feasible.
And that efficiency was a huge breakthrough. Before CNNs, image recognition systems struggled with vast amounts of data and complex images. But with Yann's approach, you could train models that actually learned to spot objects, faces, handwriting, you name it.
His early work dates back to the late 1980s and early 90s, specifically the development of the LeNet architecture, which was used for reading handwritten digits like those on checks or mail.
It's mind-blowing to think about that now because handwriting recognition feels so basic today. But back then, it was a major challenge. And fast forward a couple of decades, Yann's architectures formed the backbone of modern computer vision systems, from self-driving cars identifying traffic signs to medical imaging tools detecting tumors.
In fact, Yann's work set the stage for what we call deep learning today, large, multi-layered neural networks trained on massive data, capable of remarkable pattern recognition across text, speech, and images.
But it didn't end with academia. In 2013, Yann joined Facebook as their chief AI scientist to lead their AI research lab, now part of Meta.
Right. That move didn't just bring academic insight into the tech world, it accelerated the practical use of AI at scale. Facebook, now Meta, needed robust computer vision to analyze billions of images on their platform.
For example, think about automatic content moderation. AI needs to scan uploaded photos for harmful content, which requires a powerful and reliable vision system. Yann's expertise in convolutional nets and deep learning was invaluable there.
And under his leadership, Meta invested heavily in AI research, not just image recognition, but also natural language processing, robotics, and virtual reality applications. Yann has been a vocal advocate for open research and collaboration, pushing the industry toward transparency.
What's interesting, though, is that even with this academic rigor, Yann is known for being pretty pragmatic. He knows AI is not magic. It needs engineering, real data, and careful tuning.
Yes, he stresses that AI systems must build on solid mathematical foundations, but also require experimentation and iteration on large-scale data. It's that balance between theory and practice that marks his contributions.
And in business, that's a lesson we see play out all the time. You can have the smartest algorithms, but without the right data and application, they won't deliver value.
Speaking of algorithms, Yann's influence is not just limited to CNNs. He's contributed broadly to energy-based models, unsupervised learning techniques, and more recently to reinforcement learning and robotics.
Right, and that shows how a deep understanding of the fundamentals helps address a variety of problems. For instance, in healthcare, convolutional networks help analyze medical images for early detection of illnesses, saving lives.
And in finance, CNNs help detect fraudulent transactions by spotting unusual patterns in data streams that have spatial or temporal structures.
Another exciting application is in autonomous vehicles. The car's AI uses CNNs to see and interpret the environment in real time, recognizing pedestrians, road signs, other vehicles, all critical for safety.
Yann LeCun's legacy, then, is not just a single invention, but a framework, a way of thinking about data and learning that powers a wide array of AI applications today.
Absolutely. What's cool is that as AI evolves, his ideas on representation learning, how systems create internal models of the world, become even more relevant.
It's worth noting that Yann shared the 2018 Turing Award, often called the Nobel Prize of Computing, with Geoffrey Hinton and Yoshua Bengio for their work on deep learning. This trio essentially jump-started the AI revolution.
And because of them, businesses across industries have radically transformed how they operate, from personalized shopping recommendations to real-time translation services.
To wrap up, Yann LeCun embodies how theory rooted in neuroscience models can lead to practical technologies that touch billions worldwide.
Plus, his move from academia to a corporate AI lab illustrates how bridging research and business accelerates innovation.
So, here's today's key takeaway from me. Understanding foundational models like convolutional networks helps you grasp why today's AI systems can see and interpret images so effectively.
And from my side, when you hear about AI in your business, remember Yann LeCun's work is behind much of what makes those AI-powered apps and tools smart, reliable, and practical. It's about smart architectures meeting real business needs.
Next episode, we'll profile Demis Hassabis, the visionary behind DeepMind and AlphaGo, pushing AI toward new frontiers.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your questions or comments, which might show up in upcoming episodes.
Until tomorrow, stay curious, stay data-driven.